Hey everybody, I'm Allison and I'm here to review the central limit theorem with you. The central limit theorem proposes that with a population mean of mu and a population standard deviation of sigma, with repeated large sample selection, typically greater than or equal to 30, if we were to plot the means of each individual sample as a distribution, the distribution of the sample means is going to be approximately normally distributed. This is true regardless of whether the population the samples were drawn from are actually normally distributed or skewed. So to illustrate this point, let's use a fun example. Suppose we wanted to gather the weights of all the kittens here in Western Mass. We take an initial sample of 30, take their weights and plot them and get the mean. Get another sample of 40, take the mean weight, plot it, and then do the same with 50, and so on and so forth. If we do this enough times and we gather all the possible samples of kittens from the population, when we plot the sample mean weights, the mean of the distribution of samples is going to be approximately equal to the mean of the population. The standard deviations are also going to be essentially equal in these two distributions. The central limit theorem is an important concept in stats. For example, when we do null hypothesis significance testing, we use our knowledge of the central limit theorem and our knowledge of sampling distributions to be able to compare individual scores to some other normative value. Then, when we're able to draw conclusions about our selected sample and how it may or may not be representative of the larger population from which it was selected. I hope that's a good refresher on this concept, and thanks again for joining me.